Hello everyone, so we're going to go ahead and talk about long division and synthetic division today. So let me go ahead and hide everything here. Awesome. So let's go ahead and start with this warm-up, and the warm-up is asking us to sketch this function. So I want you to go ahead and pause the video and sketch this function for me. Okay, so pause the video, give it a try. And I'll show this here. So I see f of x is x plus 2 squared, and I have all of this x minus 1 squared. So the first thing I'm going to go ahead and do is I need to know how the end behavior is going to look like, and that refers to the parent function. So the parent function here, I see that this x has an exponent of 2, and this x has an exponent of 2. So ideally, I should have x times x, and then here I have x times x. So I have a power function, a parent function of x squared. X squared is a parabola, it's a quadratic, and it is positive. So therefore, I should have my end behavior looking something like so. Okay, so I have something like that. So my parent function is x to the 4th. The next thing that I want you to know is that we have zeros. We have x-intercepts in these values. And the way you're able to find it is that this right here is in factored form. When it's like this, when we see this in parentheses, meaning that we can take every single factor and set it equal to 0. So x plus 2 equals to 0, and x minus 1 equals to 0. And you just solve for x. So according to this, I got x equals negative 2. At x equals negative 2, my height is 0, right? And I'll just write that here, x equals negative 2. And I also have another 0 at x equals 1. So right over here, x equals 1. So according to this, I'm going to have the graph either cross or touch at that point. And my degree is 4 because my exponent, largest exponent, is to the 4th, x to the 4th. And we saw that our zeros are x equals negative 2 and x equals 1. Okay. So go ahead. Sorry about that. Alrighty, so let's go ahead and begin. So what I want you to know is the following. I have this right here, this entire parentheses, x plus 2 to the 2nd, has a multiplicity, right? The exponent here on this factor is a 2. So it is even. And what do we know about when the multiplicity is even? In this case, a 2. It's going to go ahead and touch, right? The x-axis and bounce back. So keep in mind, the left-hand side was starting from here. It came all the way from positive infinity. And we're just going to go try to connect at this point. So I'm going to see that it's going to reach right here. Okay. Alrighty. And it touches and bounces back. So it's going to go back up. The next value is x equals 1. And we got that from this factor, x minus 1. We can see that it is also squared. So it's also going to go ahead and bounce. And you can see that it reaches this endpoint right here. Okay. How do we know where it touches the y-axis? Okay, so all we have to do is notice that this right here, this is x equals 0. So if we substitute 0 into this function, we get 2 squared, and then we get this negative 1 squared. So we should see that this gives us a positive 2. So it touches right here. By substituting x equals 0, we're able to see that we got a pretty good sketch of this function. And the multiplicity at x equals 1 was even as well, and it touched. This is so cool. So we got a pretty good sketch. We didn't even use a calculator. Just by looking at the multiplicity and the parent function. The next thing that I want to go ahead and talk about is the end behavior. So as x goes to the right, as x goes to infinity, what is my function doing? What is y's doing? As x goes more and more to the right, my y's are going up, 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 up. My y's are also reaching positive infinity. Let's think about it backwards on the opposites. As x goes to the left, so as x goes to negative infinity, what is my y's doing? They're going up, 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 right? It's following this arrow. So they're also going to positive infinity. So keep in mind, end behaviors using limits, that's pretty much what it means. What is a y doing as you go towards the end points, the end behavior, okay? So let's go ahead and continue. So just looking ahead, this is what we got going on. We have a quiz on Friday to talk about all of chapter 2. Okay. Oops. So let me continue. Alrighty. So today we're going to go ahead and use long division and synthetic division to go ahead and find factors of polynomials. Okay. So what I want you to do is pause the video and divide. So I want you to think about how you first learned division. It might have been with shapes. You go ahead and draw those shapes and you divide it by the group that they're asking you. However the case may be, I want you to think about when you first learned how to divide. And then I want you to try to divide this one using some sort of algebra. Okay. So pause the video, give that a try. So hopefully you're able to get something like this. 2 times 3 gives me 6, and I go ahead and subtract it, and I see that there is a remainder of 0. So 2 and 3 are factors of 6. Okay, so easy peasy, right? Not that bad. Go ahead and try 35 divided by 2. So go ahead and pause the video. If you are struggling, I went ahead and wrote down the steps right here, so you can remember how to divide. So I'll go ahead and do this with you, and we can see that 2 times 1 gives me 2, and if I subtract it, I get a remainder of 1, and this 5 right here, I drop it down, right? Bring it down. So now I have 15. Now I'm trying to get as close as possible to 15, or something that equals 15. So 2 times something will give me 15. So hopefully you're able to see that 2 times 7 is 14. And if I subtract it, I get 1. So I get a remainder, right? A remainder of 1. Or if you want to continue doing that, simplifying it, we go ahead and put a decimal. We drop a 0 down. And we get to see that there will be a 17.5 as our solution. Or 17 with a remainder of 1. What I want you to know is that this right here is very middle school-ish, and it's not quite pre-calculus. So what I want you to do is whenever you see a remainder of some number, you automatically put it as a fraction, and this will be your denominator. So 17 over 1, and then this is 2. 2 in the denominator. Sorry, that's a 2. Made it worse. 17 and a half, which is the same thing as saying 17.5. Half, 50%. Cool. Alrighty, let's go ahead and try the next one. So I want you to go ahead and see that this is not much different than actually dividing with polynomials. So let's go ahead and pause this video, and I want to see how far you can get. So go ahead and pause the video and set this division up. Okay, so go ahead and set it up doing the same procedure you just did. Right here we have 3x plus 2, and I'm going to only focus on the first term, just like I did in my previous example. Something times 3x gives me 6x squared. So let's just focus on the 3 and the 6. Something that is 2, right? 2 times 3 gives me 6, and I need x squared. So this is probably going to have an x. So if I go ahead and do that, 2x times 3x plus 2 gives me 6x squared, right? If I do FOIL, plus 4x. So that's what's going to go right here. 6x squared plus 4x. Okay. And as I mentioned before, you are subtracting, right? Just exactly the same. And we subtract every single thing. So 6x squared minus 6x squared, that is 0. Same number, opposite signs. Now 7x minus 4x. So 7 apples minus 4 apples, that gives me 3 apples. So 3x. And I bring this down, plus 2. Okay, we're back to step number 1. Step number 2. And we need to find something, right? Something that will go ahead and multiply to give me 3x plus 2. I have 3x plus 2. Well, aren't those identical? So I can multiply by a 1. It is a positive, so I'm going to add. And that gives me 1 times 3x plus 2, which gives me 3x plus 2. Just to check my work, 3x plus 2. And I subtract every single little thing, and I get a remainder of 0. There's a remainder of 0. Okay, so what I want you to know is that 3x plus 2, the big idea here is this right here. These two are factors because they have a remainder of 0, right? And if you go ahead and do FOIL, guess what, guys? This gives us what we just divided, 7x plus 2. If you go ahead and do your distribution by multiplying these two terms, you will get this right here. Okay, so go ahead and try this one. Very, very similar. So go ahead and pause the video and give this one a try. And I'm pretty sure you're going to be able to get it. So welcome back. Hopefully you were able to get this answer. So we have 2x squared and I have only a little x, right? So there needs to be something that multiplies to 2x. So first of all, I see that this is a 1, this is a 2, so I'm pretty sure I'm going to need a 2. This is right here. This is just an x. This is x squared. So I'm going to need an x. And just to confirm, this is 2x times x plus 2. And I can go ahead and distribute this. This gives me 2x squared plus 4x. So very, very similar to the other example. Okay. And all you have to do is subtract. So we can get to see that this is 0, 7x minus 4x, right? We can go ahead and see that it's 3x, and I bring this down plus 6. Okay. So now what I want to do is I want to go ahead and find out what times 2 x plus 2 gives me 3x to the 6. So hopefully you're able to see that this is 3. And if I do my distribution, I get 3x plus 6. And it's nice that it is the same term, because if I divide this, I get a remainder of 0. And this right here is my 3. This was the term that multiplied to the x plus 2. So ideally, the x plus 2 and 2x plus 3, if I was to distribute them, it will get me this right here, plus 7x plus 6. Okay, so these terms, this right here is a factor of this right here, of this polynomial. And we were able to do this by using long division. Now, is it the only way? Of course not. There's plenty of other ways, but this is a nice way to know. Okay. Next one, I want you to give this one a try. And this one will have a remainder, and it's perfectly fine because we're going to see what happens when that is the case. So I got x minus 1. I got 2x squared minus x minus 2. And I'm going to go ahead and do my division the best way I can, right? So I have x right here, and I have 2x. Use different marker. Okay. So I got x. I got 2x. So I'm pretty sure I'm going to need a 2 and an x. And if I distribute it to each term, I get 2x squared and 2x. Negative 2x, sorry, because the 1 was negative. And don't forget that you are subtracting. Okay. So let me go ahead and change markers. Green works. So 2x minus 2x, that's 0. Oh, here, dilemma. Negative x minus a minus. Well, that makes my 2x positive. So it's going to be a negative 1 plus a 2. So that's just a positive x, right? And you can write the 1, or you can leave it as it is. And don't forget to drop down the negative 2. Okay, so it looked a little bit confusing, but remember, negative times a negative made the 2x positive. And if you just subtract 1 from 2, it's still 1. Okay. You can think about it in dollars. You have $2, someone takes away 1, and you have just $1 left. So the next thing is to go ahead and find out what gives me x minus 2 if I only have x minus 1. So I'm going to go try to match up this right here, the x's first, so I can see that I can go ahead and multiply by 1, and I get x minus 1. And all I have to do is subtract, and I get that negative 2 minus a minus 1. that is -2 plus 1, that is a -1. So ideally, whoops, and I keep forgetting this number that you found, that you don't forget, like me, to put it here. Okay, so we found out that there's a remainder of -1. So the way you write this is that the solution for this is x plus 2, I'm sorry, 2x plus 1 with a remainder of -1. So that's ideally how you learned it in middle school. In pre-cal, you're going to go ahead and write it like so. 2x plus 1, instead of saying r -1, you're going to put -1, whatever that number is, -1, over this right here, x minus 1. Okay, the same values right here, term that you divided by is what you're going to have. And that is very similar to what we just did on the first example, where we had the remainder of 2 on the 17 right here. Remember how we just did it right here. And it means the same thing, guys, just that this is a lot more, what can I say, more accurate for our pre-calculus class, okay? Okay, let's go ahead and continue. I got a little meme for us. So I know it looks a little cheapy, but this one's one that I made. So how you learned division and then how it is now. So feeling old yet, guys? Alrighty. The next thing that I want you to know is called synthetic division. So synthetic division is more appealing to students, but what I want you to make sure is that both of them work the same way. However, this only works if you're being divided by only one term, right? Only the x plus 2 or x plus a constant, something like that. Something you can, something you don't have 2 factors in the bottom. You know what I'm saying? Okay, so how does this work? Well, honestly, synthetic division is more appealing because the students don't really see all these variables. They only care about the constants. They only care about the numbers in front of these variables. So pretty much what I'm saying is you get the numbers. Let's say this number right here is 1, right? That we didn't write it because it's a 1. And you put it right here. You get this -1. And the same thing, you put it right here. And you get the -6, and you put it right here. So honestly, all you do is the numerator, you break it up, you keep only the numbers, whatever the number is, with its sign, guys, very important, keep its sign. If it's minus, it's negative, it's plus, it's positive. Okay, the next thing you have to do is this x plus 2, you go ahead and solve for it. X plus 2 equals 0, x equals -2. So whatever that value is, it goes right here. Okay, the next thing that you do is you bring this down and you multiply. Go ahead and multiply, and then whatever that is, you put it right here. So -2 times 1, that's -2, and you add. So you do this procedure of multiply, then bring it up, then add, then multiply, then bring it up, and I have it there for you guys. Oops. And honestly, it's not that bad. Okay, and I have the steps on the next slide. So these are very good steps in case you need that algorithm. So I'm going to encourage you guys to try this out. So just try the setup. Pause the video, try the setup, and see how it goes. And I'll do it the same. So we get the coefficients. In this case, I got a 2, I got a 5, and I got a -12. Keep in mind, if you're missing a term, let's say this was, we didn't have an x here, like we just went from x squared to -12, then we're missing a degree, right? Because this is degree of 2, this is degree of 1, this is degree of 0. If you're missing one, you would have to put it as a 0. That's very important. Okay, so get the constants, the 2, the 5, and the -12, and you put them here, 2, 5, and -12. Okay, we go ahead and use the denominator, what we are dividing by, and set it equal to 0. So x plus 4 equals 0. X must be -4. -4 goes right here. Okay, so the first step tells us to bring down the 2. Nothing happens to the 2, and it's golden. It stays there. Okay, the next step is you multiply. So -4 times 2 gives me a -8. Okay, then I'm going to go ahead and add these two terms together. 5 minus 8, that gives me a -3. Okay, and we repeat the procedure. -4 times a -3 gives me a +12. and I'm going to go ahead and add these together, and I get 0 as my remainder. This is what your remainder is. So we can see that this is a factor. And you're probably thinking, what the heck does 2 and -3 mean? Well, that's a great question. So what this means is that these will be the terms pretty much in there encrypted are the actual, what I would say is the solution of this will be the factor itself, since this is 0. So we saw that this was a degree of 2. That must mean this is a degree of 1. And this right here looks more familiar. So our answer is 2x minus 3. Okay, and if we were to do the same thing, if we were to multiply it, x plus 4 would give us 2x to the second plus 5x minus 12. So we can see that these two are factors of this entire term. So very, very important. After you do this, you can go ahead and see that this is a degree of 0, this is degree of 1, and if you had another number, degree of 2, degree of 3, and so forth, depending how many numbers you have. Okay. I believe this is my last example, so go ahead and try this one out, and I keep in mind it will have a remainder, just to make sure we understood that stuff. Okay, so go ahead and pause the video, give this one a try, and I'll set it up here. So remember this right here, so hopefully you're all the way back here now. You were able to pause the video and give that a try, and I have these terms, so 5, 18, -11, and 6. And I can see here, let me get my highlighter. I can see here that the degrees are in order 3, 2, 1, and 0, right? There's no x, so it's x to the 0 is 1. So there is no x, so I'm gonna see it's 0. So since it's in order, I no longer need, I do not have to put any gaps in here. But if there was one missing, you would have to put those gaps. Okay, the next thing is x plus 3. X plus 3 equals 0. That gives me x equals -3. That goes right here. And it's the same procedure that I've been doing. I bring down the 5, nothing happens to it. Nothing happens to this first term. And after that, I multiply. -5 times, -3 times 5 is -15. And I go ahead and add these two terms. This gives me what, a positive 3. And I'm going to go ahead and add, I'm going to go ahead and multiply -3 times 3. That gives me a -9. Okay. And if I go ahead and add these together, I get a -20. Okay. So far, so good. All right. So far, so good. The last part is to multiply, right? The multiply. -3 times -20. That gives me a positive 60, right? And negative times negative give me a positive, and all I have to do now is add these two terms together. So 60, positive 60 minus 6 gives me a remainder of 54. So keep in mind, if this was right here, this is x cubed, that must mean this is x squared, this is x, and this is just a term as x to the 0, right? And we know that x to the 0 is equal to 1, so I'm not going to write the x there. So my answer should be a 5x squared plus 3x, because if it's positive, it's a plus. And if it's negative, it's a minus, with a remainder of 54. Keep in mind that that is a nice way of saying it, but in pre-calculus, we're going to go ahead and write it, the remainder, correctly, as in saying the plus 54 over whatever you divided by. So in this case, it's x plus 3. Look how beautiful that is. This would be our solution. So is this a factor? I'm going to say no, because I had a remainder that we did not account for. The remainder was not 0, but we are still able to get a lot of information from this, especially once we get to asymptotes and behavior about these asymptotes. So hopefully you enjoyed this lesson. It is a good, nice review from Algebra 2, or if you're just learning it now. But if you do have questions, leave them in the comments and I'll gladly reach out to you the best that I can, or send me an email and I'll help you out. Okay, the practice problems here are on your notebook. So just to drill down the idea of this. So I do want to see your work on this, because I do want to write on it and give you feedback. Okay, And the exit ticket that I want you to go ahead and try. So go give this one. And again, I want to see the work. Okay. Awesome, guys. As always, it's been a pleasure. And thank you for joining me. Laters.